everyone. Thank you for attending tonight. As Hernan said, my name is Ron Lowry. I'm the Eastern Area Manager for Hazard Control Technology. So I handle the eastern half of North America. That's the U.S. and Canada, Mississippi River, kind of east to the coast. In addition to my role at HCT, I've also got 37 years in the fire service. As of this week, I am now the chief of my volunteer department here in Pennsylvania. Our former chief resigned last week, and I was appointed chief of the department. So I'm now a fire chief. I'm pro board firefighter 1, firefighter 2, and EMT. So again, we're going to get started here on the presentation. What we're here to talk about this evening is Class D metal applications. And the fire hazards that are associated with them. So, you know, when we're talking about Class D metals, we're talking about things magnesium, titanium, zirconium, zinc, aluminum powders, you know, and what we're trying to do is find that a suppression technology that's going to be effective at handling those Class D fire emergencies once they've grown beyond that incipient stage. So most of the powder dry chemical extinguishers that we typically deal with are, you know, they're good for small scale incidents, but when you have something larger like the photo here with the vehicle fire, they're very impractical. So let's talk about a solution for those types of incidents. So, you know, when we talk about how prevalent is that Class D hazard in today's environment and where can we expect to find it? Well, things like motor vehicles, you know, the use of magnesium and titaniums and other exotic metals just seems to be rising almost, you know, year to year. With each new model year, there's more metals. Things like sporting equipment, you know, golf clubs with titanium drivers, mountain bikes and, you know, over-the-road bicycles that have high-end metals in them, recycling centers or scrap yards, 3D printing, which anybody for the most part can get a 3D printer, but a lot of that's done with powdered metals, be that titanium, magnesium, zinc, you know, other metals that are used in the 3D printing industry, and then machine shops that are milling down, you know, blocks of magnesium or titanium to actually make parts, and then various manufacturing facilities where they may be forging those metals. So, you know, what are we currently doing today to handle these emergencies? Well, you know, I can tell you from the fire service point of view, the first thing we go to is water. And of course, that's totally not the solution because, you know, water is reactive on Class D metals. The same way with your foams, both Class A and Class B are both reactive on that Class D metal. We do have the Class D metals extinguishers, which is the most popular choice, but they're limited to those incipient stage fires, and they can't handle the other classes of fires that may be involved. And then it seems like the solution of last resort is, you know, get a truckload of dry sand and try and bury the fire in sand. But again, not a very practical solution for a larger type incident. So what happens when we do these fires the wrong way? These photos are of a manufacturing facility in Michigan. They produced magnesium car parts. This is that magnesium facility, and you're going to see here in a second what happens when we do it wrong. So, you know, water going on to that magnesium application, and those are the results that you can have. So, you know, when it goes wrong with magnesium, it tends to go wrong in a bad way. Same way, this is some photos of some various fires they've had out in California with titanium, involving some titanium recyclers.
Everybody all right? Everybody all right?
So there already, before the video started, there was a small explosion involving the titanium.
Is everybody all right? Everybody all right? Okay, guys.
So as you can see, even after that first explosion, they're still continuing to flow water on the fire.
Okay, guys, I want you backing off. Go off the line, back off. Mike, let's pull out and go defensive. We're okay. All right.
Shut down the 2.5-inch line. Shut it down.
21s, get out of there.
So as you can see from that previous explosion, there's all those small fires spreading around. That's from the titanium that flew out from the first explosion.
Mike, we're gonna have.
Are you working on the east side of the fire?
In just a second here, you're going to see a catastrophic event.
Benji, get a line.
We've got other containers of titanium taking off right now.
Hey, Dozer, you want us to take it around from the other side, around the. Let's get out! Everybody out! God damn it!
So this incident actually injured 7 Los Angeles firefighters. And then lastly, you know, I think for the fire service, for the most part, when we generally seem to run into is in that vehicle fire situation. So, how prepared are you for those types of incidents? I'm not sure that most people are, so let's look at a solution that can help you with all of those different types of situations, which is encapsulator technology. So, what is an encapsulating agent? Again, it is a type of water additive whose basic building block is a spherical micelle. That micelle is capable of encapsulating both carbon and hydrocarbon molecules, sealing them off and rendering them non-flammable. So what is F500 EA? Again, it's a fluorine-free, non-corrosive, 100% biodegradable encapsulating agent. It's UL listed for Class A and Class B fire suppression, and it's been tested and proven effective on Class D metal fires. And it can also be used as a flammable liquid spill control agent.
Encapsulator technology.
So this video here we're going to play will kind of walk you through what happens when that encapsulator agent mixes with water, how the spherical micelle is formed, and how it then interacts.
The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails or
So we're going to go back here a second, right to that very end of that video.
encapsulate.
So very important when that happens, especially for this Class D application, you now have this skin of F500 on the outside of the water droplet and millions of these spherical micelles inside. It's very important, this particular, the result of this particular solution, why it is so effective with Class D metals is because of this skin. We know water reacts because that Class D metal is burning so hot that it can actually split that H2O molecule into hydrogen and oxygen, thereby giving it a flammable gas to burn. Well, because you now have this skin of encapsulating agent of the F500 on the outside of the water droplet, that encapsulating agent is now interacting with the Class D metal, that molecule, and not the water molecule. So you don't get the reaction like you would with plain water. So that first unique feature of that encapsulating agent that we talked about is the being able to seal off hydrocarbons and render them non-flammable. All of a sudden, we're skipping through video.
Hazard Control Technologies presents F500 technology.
So as you'll see here in this video, the firefighter is going to be spilling out some gasoline on the ground. They'll treat part of the spill, removing the flammability from the fuel. They'll go ahead and ignite the fuel, and as you see, it only burns to where the fuel was encapsulated, and then it stops. That's because the majority, the balance of that fuel spill is actually encapsulated and now non-flammable. Firefighter will take that hand line now and finish extinguishing that fuel, eliminating the fire, and again, encapsulating the fuel that's left, taking away the flammability. You'll see here, as soon as he's done, the firefighter with the torch will come back through that flammable liquid spill, showing that it's non-ignitable, non-flammable. So even disturbing it, like if you would have a foam blanket and would disturb the blanket, you would have flammability. The next unique feature is that rapid cooling. So again, as we talked about, that F500 forming a skin on the outside of the water droplet actually absorbs the heat and then transfers that heat energy to the interior portion of the water droplet, drastically cooling the metal, which is why it's so effective on a Class D metal fire. So this is titanium here. We're going to go ahead and extinguish these with an F500 extinguisher with 10 ounces of F500 in the extinguisher. So again, no reaction to the metal. And as you're going to see here, we cool so rapidly that the titanium can actually be handled barehanded. It's that cool already. So it goes from burning at a couple thousand degrees to literally ambient air temperature in a matter of seconds. And then that last unique feature, and one of, I think, the most important ones, is the ability of F500 to actually stop the smoke and the toxins in the smoke from even forming. So interrupting that free radical chain reaction, which then gives you improved air quality, improved visibility, and a drastic reduction in the toxins in the smoke. And this video here actually really drives that point home as to the effectiveness of improving the environment when the agent's used, that fire environment that we see. As you'll see here in a second, we're going to be attacking this tire fire with a 1% solution of F500, and just that rapidly, the smoke disappears. So that black, heavy, toxic-laden smoke rapidly disappears when the agent is used because it's interrupting that free radical chain reaction. It's stopping that soot and those toxins from within the smoke from even forming. So again, as you'll see here, rapid cooling of the tires as well. So let's talk about the particular application of F500 with Class D metals. So how do we want to try and attack these types of fires? Well, first you want to ensure that you're actually flowing that 3% solution of F500 prior to attacking the fire. So if you aren't using an extinguisher and you're using a hand line like the photo on the left here shows with a vehicle fire, you want to have your adductor preset at 3%, and you want to flow that hand line and ensure that you have F500 in the line prior to attacking the fire. And you'll know you have it because when F500 is added to that water, the solution almost has a skim milk to a 2% milk appearance when it's flowing out of the hand line. So once you know you have F500 in your hand line, you know you're safe to attack the fire. Then particularly on the Class D metals, you want to go in with a dispersed pattern to start cooling down that metal, taking it from a burning white hot more down to an orange glow. So again, you want to keep some distance. You want to rain down the solution onto the burning metal to start the cooling. Again, once that metal goes, like the magnesium, from burning white hot to a more orangish glow, you can go ahead and tighten your pattern up a little bit from that wide 20, 30 degree dispersed pattern to a little bit more of a straight stream to help to more effectively cool and complete extinguishment. If once you start doing that, you start to get a little bit of a reaction from the metal, just go ahead and open your pattern back up, continue to rain it down until you get it cold. So the video here we're going to do, again, this is titanium and zirconium shavings. Again, with an F500 extinguisher, with a 3% solution of F500 in the extinguisher. So your incipient stage fire applications. So again, kind of like you would with a regular incipient type fire with a Class D extinguisher. But as you can see with the F500, as opposed to a Class D extinguisher, a traditional powder one, we're not attempting to form a shell of powder over top of the Class D metal and smother it. We're actually cooling, suppressing the fire and cooling the metal, thereby eliminating the hazard. You know, if you would use a powdered Class D extinguisher with this, you're going to have to leave that pile alone, avoid that work area until metal can naturally cool. Because if it's disturbed and that shell is broken and it's exposed to oxygen, it's going to start free burning again and you're right back to square one. So that was kind of like the incipient stage application.
Hazard control.
Next one here, this is actually, again, a smaller stage fire, but something that's a little tougher to put out. This is actually some burning magnesium. This is a magnesium lawnmower deck. The old Lawn Boy lawnmowers were famous for being made out of magnesium. The base of the lawnmower
this demonstration for the Burlington Fire Department.
So again, as you saw, he was flowing a hand line there off to the side, ensuring that he had F500 in the line. He's using that dispersed pattern there from a distance and just kind of raining it down onto that metal, allowing the agent to cool it off. You'll see he keeps pulling the nozzle off every once in a while, seeing what kind of effect he's having. Is it cooling? You know, is that metal going from that bright white more to the orange? Now you'll see he's going to get in here a little closer for a little bit more direct attack to finish the extinguishment.
Today's car fires and are very dangerous to the firefighter applying water or foam.
Again, so as you see there, 42 seconds. He's going to walk up again, remove his glove, and can now handle that mower deck that just seconds ago was probably burning at 3,000 or 4,000 degrees with that magnesium.
So, say in a vehicle fire, and that's typically where you're going to get most of your Class D stuff, you guys, or in a commercial.
And then this last video here, it's again, we'll go back to what we normally face in the fire service when we're dealing with Class D metals. This was a training we were doing of a vehicle fire. This particular one, when we get around to the far side, as you'll see, actually has a burning magnesium seat frame and steering column. So for this particular application, we're using the F500 TKO nozzle. It's a 20 gallon per minute self-adducting nozzle that holds the agent right there below the nozzle. So it's really, I think, a great application like this on vehicle fires because it gives you the ability to adjust the percentage of F500 you need right there at the nozzle, be it 1% or 3%. So again, rapid knockdown, that's only a 20 gallon per minute flow. So we probably had about 30 or 40 seconds into that. So we maybe used 10, 12 gallons of water or solution so far on that fire. As you'll see there, it was a little tight. Didn't realize we had magnesium. Now using that wider dispersed pattern, letting it rain down on the magnesium. Move here in a second to get a better angle on that steering column. We're going to move to the front of the vehicle here in a second. So that's one of the keys with anything. You have to get agent onto the fire to put the fire out. So as you can see there, once I finally got the right angle and was able to put agent directly onto that burning magnesium, it really rapidly completed that extinguishment. So again, if you were using the traditional extinguisher, you have the issue of needing water or another agent to actually put the burning vehicle out. But then that's reacting with the Class D metal. So you're trying to use a Class D extinguisher to extinguish the Class D metal, and you're going right back to, if the vehicle's still burning, needing to use water to finish suppressing the vehicle fire. You're almost chasing your tail time and again when we're looking at those types of hazards and how we handle them with a multi-agent or a dual agent suppression solution as opposed to F500, which is a one agent solution that can handle all of the different classes of fires that may be involved in something particularly like a vehicle fire. So let's take a look at some of the delivery equipment that's available to allow you to apply the F500. So as you saw in a couple of the videos, is the F500 extinguisher. Great application for the Class D metals, especially in the incipient stage, those smaller fires that you may have. The F500 extinguisher with the water mist wand is really superior for those small Class D metal fire applications. As you just saw there with the vehicle fire, we have the TKO nozzle. Again, self-adducting nozzle holds 2 liters of agent directly below the nozzle. Gives you the ability to adjust the percentage of F500 from 0.5 to 3%. Really a good option for those, small to mid-size type applications when we're talking about Class D metal fires. And then we have some of our larger extinguishing units. We call these our QAMUs, our quick attack mobile units. So these are pressurized, almost like giant wheeled pressurized extinguishers. They come in 25, 50, 75, or 100 liter options. Again, pre-mixed with a 3% solution and pre-pressurized, so they're ready to go. Great things with these is there's no downtime. If this is in an industrial setting, your folks right there, you can just recharge them right with an air chuck and an air hose off of a compressor system. So right after the application, you can go ahead, recharge your QAMU on your own, and you're right back in service, ready to handle another emergency, as opposed to if you're using, you know, some Class D, the current Class D powder extinguishers, you know, you have to send those out to be recharged and wait to get replacements in. This allows you to get your coverage back rather quickly in the event that you have an incident. And then the last thing here is our F500 carts. So what this is a reservoir of F500 concentrate, two sizes, 100 liter, 150 liter. It's about 26 gallons in a 40-gallon cart. Has a 60 gallon per minute eductor mounted right to the cart that draws the agent out. Comes with 50 foot of 1.5-inch fire hose with a 60 gallon per minute matched nozzle. So these would be for your larger facilities, you know, potentially there for the fire department to use when they get on scene, maybe a metal recycling facility and or a, you know, like a machine shop that handles large amounts of Class D metals, and you need something more than just the smaller suppression capabilities that the extinguishers and the TKO can actually offer you. And then the last thing is our concentrate control systems. So the F500 can actually be added directly into a sprinkler system. So if you have currently, you know, maybe moving into a new warehouse facility or something that currently has a water-based sprinkler system, but you're going to have Class D metals in there, we can go ahead and add the F500 directly into that sprinkler system, be it a bladder tank, which is pictured there on the right, or we can also do a water-driven proportioner or a balanced pressure pump type system to ensure that we're educting the correct percentage of F500 for the needed fire flow that you have. And we have an engineering department that can work with your sprinkler contractor to actually design the perfect system to meet each customer's specific needs. So got through that a little quicker than I thought I was going to. Do we have any questions from anyone? First question is F500 capable of being dispersed through a CAV system, a compressed air foam system? Yes, it is, but as we saw in a lot of the videos, the F500 is not a foam, it's an encapsulating agent. So what I would tell you is you can use that CAVS unit as the way to proportion the F500 into the line, but you don't need your air. The agent will actually work as if you would aerate it, it's still going to work. It is just much more effective in a water-based solution. So without that extra air added to make the bubbles, you don't need the bubbles to make F500 work. It actually works better in a aqueous solution. So as more of a water-based.
Can I interject here?
Yes, sir.
Yeah, Phil, McQueenie Fire. We already have F500, so I've actually used this stuff and done some of this magic that you're showing these folks. But I wanted the one thing toward the front you did that was, I'll call it the science slides. I was wondering if you could share that with us. I wanted to use that to educate the troops.
Yes, of
Yes,
course.
absolutely. So everything we've presented here today, you know, probably within the next week or so, Hernan will get, you know, both the PowerPoint slides and the presentation and the recording out to the whole group.
Oh, great. Yeah, I actually had the case where I ran into well, we had a grass fire that almost turned into a structure fire, and I found a pickup truck that was on fire, so I put the truck out, and I had a hose, you know, and then I swept the hose over the back of the truck, and lo and behold, I got all these cute little white sparks flying at me. And so I had one of the guys get me a can, and he says, I only got a gallon of water left. And I said, okay. So I got the can and put my thumb over the end of it, it's a jet nozzle, and sprayed this white hot magnesium, I think it was a wheel, and put that thing out with 1 gallon of water.
Yeah.
People think that's a UFO story, but
Was that 1 gallon of water or 1 gallon of an F500 solution?
oh, F500, yeah.
Okay, thank
That
you.
was like 3%.
Yep, exactly. Yeah, it's like you said, it's seeing is believing, and you really do have to see it yourself sometimes. How quickly you can cool with how little agent, how little a solution you need to actually achieve the extinguishment.
Yeah, we actually, I had set up, we were doing training on the fire field, and so we set up pallets, and they kind of lean them together in an A-frame, if you will, and then stuffed them with hay, and then lit it up. And we had multiples, and we had 1 can that was just plain water, and then we had another can that was F500, 3%. And so we actually put them on a stopwatch. And the water can, they're both jet nozzles. The water can put the hay out predominantly, if you will. Maybe there's a little flicker here and there. In about 1 minute. The F500 put the entire thing out, and we let them get stoked up really high. And the F500 can put it out in 19 seconds.
Wow. Chief, I can tell you that animation video talking about how a spherical micelle is automatically instantaneously formed, and then how everything orients on the droplet. That's on our YouTube channel. Also, the Vimeo channel is standalone videos. But I know Hernan will be sending everybody the PowerPoint, but if you needed that from an instructional point of view, it's there. Or Jeff Monkowski, who's on the call here, could also just get you a hyperlink to that.
Should I call Ron or Jeff?
Jeff, yeah, you're in Texas, so Jeff will be the guy to talk to, and he can get you hyperlinks to, any of those videos for standalone if you wanted to use them in a training session.
Yeah, I talked to San Antonio Fire. I talked to one of the captains down there, and he says, we don't need anything but water. Okay. So, I mean, lead a horse to water, but we're happy with the stuff. We got everything loaded up with it. Cans, brush trucks, engines. So.
Well, I know Ron didn't cover it in this presentation, but the F500 actually interrupts the free radicals from coming together, and when they come together, it forms toxic soot and smoke. And then inside any type of an interior attack, the fire puts off benzene, and the F500 encapsulates benzene inside the spherical micelle. So, quite frankly, the F500 is, as far as we know, the only proactive material in the firefighting industry that can reduce your exposure to toxic soot and smoke and carcinogenic benzene. And I know nowadays all the fire departments, when we ask, what are you doing to protect yourself from cancer? We always get, we use wipes, we take our bunker gear off, we don't allow it to come back to the station, we decon, and all those are really good things, except they have one thing in common. They're all reactive after you've been in a structure fire, and this agent can actually be proactive to reduce what you're exposed to. And I think when departments start to find that out, they start to go, maybe we're actually bringing a knife to a gunfight when we're just bringing plain water.
I was going to ask you, since you're talking about bunker gear, I don't want to monopolize your talk here, but quick question. So I've been thinking about, which I haven't had time to experiment with everything that I wanted to do, but I was going to, we've got a firehouse, of course, and so sometimes we really crank that thing up it's gone over 1,000 degrees, which is kind of nuts. But what I was wondering is spraying down the troops before they go in, where they know they're going to have a significant heat, go in, spray them down before they go in, would they sense less heat? That's the question.
I would say yes. The answer to that is yes, but I think you may actually accomplish more by just having 0.5% in your hose stream and open up to about a 15-degree fog pattern, Z the ceiling and come down on the fire, because it's going to absorb somewhere between 10 to 20 times greater heat than plain water. And the biggest key is without the creation of superheated steam. And I know Ron has a video. He was out doing a training with one of the fire departments, and they were amazed that they were doing thermal imaging or at least a laser barometer. They went from 1,400 degrees, Ron, down to about 120 in a matter of seconds. And the guy was standing there. He goes, "Hey, I'm standing right in the steam." And the fire chief said, "No, you're not standing in steam, because that's about, maybe 100-degree vapor, not 212-degree steam." Sorry, Ron, go ahead.
No, that's fine. Yeah, so we did a couple different variations, both with smoothbore and combination nozzles, because, fire service is using both of those in that structured fire environment. And we took, the smoothbore we were doing at a daylight fire. We had ceiling temperatures of about 1,000 degrees, a little over 1,000 degrees. And at the base of the fire, it was burning at about 1,300 degrees. We had pallets and haze. It was a Class A combustible burn building. We took the ceiling temperatures with a smoothbore nozzle down to about 250 degrees, and at base of the fire from 1,200 to 400 in about 15 seconds. When we did the evening burn with a combination nozzle, we took those ceiling temperatures from 937, 938 degrees to about 113 degrees in 15 seconds. So rapidly reducing that, the temperatures in that environment, making it a much more tenable atmosphere, both for us and, potentially trapped civilians.
Well, yeah, I'm just trying to learn more about the product. I mean, we've had it for a few years now, and we're the only department in the area that is using it. And I'm trying to convince some of these folks to use the stuff, but you need to have, even when I give them real life experience, they still don't believe it. It's still a UFO story. So I'm trying to figure out how to convince these guys, because it's going to really help everybody. I am convinced.
Chief Vasily, I'd like to add something to your statement there. When I first saw this as a battalion chief up in Maryland, I thought it was smoke and mirrors and snake oil. In fact, that's what I told my deputy chief, and he kind of laughed about it until he saw some videos. So it really proved itself. But you'll find sometimes, and this happened to two of my fire departments that use the product, that they are starting to get called mutual aid to stations 2 or 3 territories away, because they're the only ones with F500. So finally, the one up in North Carolina told the ones that keep special requesting them that you need to buy some of this stuff, because we're not going to come out and put your fires out every time just because we have the product and you don't. So that's how the word gets out. Unfortunately, one knew about it, but they wouldn't buy it, but they kept bringing this other fire company that did have it in to put their fires out.
I had a couple of questions. Can you hear me?
Yes, sir. Yes.
Okay. Louis Hall, up to Vermont. F500 and F500EA are the same thing, correct?
Yes.
Yes.
It's just sometimes we drop the EA off the name.
Yeah. Okay.
So the EA is just a short for encapsulator agent.
Yep. On your gas spill on the concrete there.
Yes.
What got flushed off? Is that an environmental hazard or not, if it's been treated with F500?
So if it's been treated with F500, it is not. The agent's actually listed on the EPA's National Contingency Plan as a soil washing agent. So it can be used to treat hydrocarbon spills on the ground.
Okay. So when EPA comes in, what do we tell them?
Well, that's your, so this is what I tell the fire departments that I work with. So you can treat that spill, if they still want it cleaned up, it still needs to be cleaned up if that's what they're requiring. But as opposed to that spill being in the ground and having it an untreated spill, and you now have a cleanup company coming to try and excavate that dirt, they're now working in a flammable, hazardous environment, trying to excavate that dirt, because it's still going to be off-gassing vapors. Now you have the potential of leaving from an accident scene to go back and service. The 2 hours later, the excavator that they were using to try and excavate the soil got too hot, and they had a flash fire because of the vapors that were off-gassing from the soil they were digging up. And now you have an excavator on fire along with the soil. At least if the soil's treated with F500, you removed the flammability and made it a safe working environment for the folks that are going to excavate the soil. But think about it, even though they excavate that soil, all they do with it is take it to a landfill, spread it out, and allow the fuel vapors to evaporate out of the soil. The F500 does the exact same thing for you. As a matter of fact, it speeds up that evaporation and bioremediation process.
Okay. On your TKO nozzle,
Yes.
how do you set the percentage?
So there's, let me see if I can go back to that slide for you here. So this knob right here on the side,
Yep.
that knob just turns. It has a 0 setting, so it's just water, then a 0.5, 1, 3, and a flush setting.
Okay. And does when you buy the nozzle, do you get a jug with it, or that's an extra?
Yes, so you'd have to buy the F500 separate from the nozzle.
And now do we get empty bottles and fill them from our jugs, or?
Yes, exactly. Yeah. So, the nozzle comes with the 1 2-liter bottle. You can buy a spare 2-liter bottle for it, so you can have it filled, ready to go if you need more than one bottle. But yeah, you just fill the bottles right out of your 5-gallon pail.
Yeah. Has anybody ever used them on round bales?
On,
Yes.
on hay
The
bales,
TKO nozzles?
the
Yes.
TKO, I couldn't.
No, well, I meant F500.
Oh, yes.
Oh.
F500 has been, yes.
That we've had round bales. Once they start, you may as well let them burn.
Yeah. I know for a lot of that, when they've done it, they've actually used a piercing rod to get the F500 into the center of the bale.
Yeah. I guess the last thing I had is I'm talking with a salvage yard about getting some mag wheels that got smashed up. Can I get somebody to come up and put on a real demo again? It's been quite a while since anybody's been here.
Sure.
And probably better bring one of those TKO nozzles with you, because that might be a thing that we would buy.
Sure. Yeah, not a problem. We can definitely get that set up.
Yeah, I'll pipe in here about the TKO nozzle. This is actually becoming a standard of the industry in Germany. That's where it first came through our HCT Europe division. It's because the F5, when you start looking at cars, they could be gas, diesel, ethanol blended fuel. You have magnesium steering columns, titanium, frames in your seats. You could have lithium ion battery. You have plastics, and the F500 is so effective on all those materials that they started using this nozzle. And the beautiful thing about the nozzle, like Ron said, is you could start off at 1% and dial it up to 3 if you encounter magnesium or titanium. Another beautiful thing is once you take the nozzle off, everything from that point back is all plain water. So you're not wasting any product. You're not pouring anything on the ground, and so that's a nice little feature that you're not deducting and wasting what you already have in the hose line. And the last thing is, people I know, when I've gone out and talked with fire departments, are like, "Are you kidding me? This is a 20 gallon per minute. We're going to attack car fires with that." You know, we're used to using a 125 GPM nozzle and unloading half of our 500 gallon tank. And when they see that they can extinguish these types of fires with a 20 GPM nozzle in about 1 minute, where you're literally only using 20 gallons, you know, wow, look about the environment. I know nowadays, at one time in the career, it used to be go put out the fire. Now it's go put out the fire and don't create a mess. And so I know everybody's a lot more environmentally conscious. So if you go back and review the presentation and look at the video, one of the things you'll notice there's very little runoff on anything that's fought with that nozzle. So I just throw that out.
What kind of a lead time do you need, Ron? Coming to Vermont anytime you know of?
My June's pretty much booked up. We're looking at July right now.
Not a problem. I have your number. I'll get back to you. Let me make sure I got the wheels and so forth.
Sure.
Sounds good.
Thank you, Luis. You have other question? Here in the chat, Ron, we have a question that said, is it fair to say that today combustible metals are in every community at any given time? So with the increased classes of fire, A, B, C, D, K, and lithium-ion, A500 will be the best choice to control fire and protect people?
Yeah. In my opinion, yes, because it takes the guesswork out of fires. So let's just take a vehicle fire, for example. As Mike said earlier, we don't know when we pull up on it. Is it a hybrid vehicle? Is it an all-electric vehicle? Is it running on an ethanol fuel? Is it running on diesel fuel? All of those questions, if you're not using F500, you need to know the answer to those questions to pick the right suppressant agent. Are you going to use water? Are you going to use an AR-FFF? Are you going to use an ARA-FFF? If you're using an ARA-FFF, are you proportioning it at 3% or 6%? Those questions all need to be answered so that you can fight that fire effectively. With F500, the answer is if it's on fire, F500 can put it out. So it takes a lot of the guesswork out of that arriving crew trying to figure out what's going to be the best solution to cover all those different classes. That's one of the really great features of F500 is that it can handle those multiple class fires at the same time.
I want to pipe up here because I had a customer once tell me, we buy foam hoping we never have to use it, but we buy F500 because it solves our everyday problems that we face. And what he was referencing was the versatility of the agent to do A, class B, three-dimensional class B fires, class D, the benefits that are brought to the table. But then he went on to say something I thought was very interesting. He goes, and you would think that if you're using the agent every day, it would be very expensive. But what we found is we have a reduction in workman's comp claims because our firefighters aren't tired tripping over hoses. They're not getting steam burns because we're reducing the heat without creating steam. And he says, and, because of the quick knockdown and the interruption of that free radical, our visibility is so good. So he said it's just the opposite. We use more F500 than we ever use foam, and our cost to our department is even lower because of the savings on workman's comp claims. So, when you think about it, that's something you need to kind of take a look at and consider is where it saves you on other aspects of the department's budget.
Another aspect might that somebody asked here, if this chemical, our agent, the encapsulator technology, have PFOS and PFOA.
No, absolutely not. We are fluorine free. So there is absolutely zero fluorinated ingredients added to the product. Fluorine is typically used to create bubbles that you find in foam. Since our technology is based on a spherical micelle, we don't need any fluorine, so we don't add any fluorine.
Yeah, thank you. And Ron, we have two more questions. One said that's one video showing the vehicle. Bring the question, is magnesium being more widely used in all vehicles or just certain manufacturers? You understand my English?
Yes, yeah. So the magnesium, the use of magnesium is across all manufacturers, and you're finding more and more of it in every vehicle. So, you know, if you would have looked back, I would say even 10 years ago, the magnesium we found in vehicle fires was generally the steering column. You know, that was the big place. You know, 25 years ago was the Volkswagen with the
aluminum black
transmission and the motor being magnesium on a Volkswagen. But if you look now, the majority of the cars, the dashboard subassembly is all magnesium. Most of the seat frames in the vehicles are magnesium now. The steering column, some of the engine support, the struts, supports underneath the vehicle are being made out of magnesium. Door panels being made out of magnesium. Pretty much anywhere they can figure to put it in to lower the weight in the vehicle to help improve the fuel economy, they're going to a magnesium or some type of magnesium alloy, if not straight magnesium.
Okay, thank you, Ron. And we have the last question that if we don't have, no, we have two more questions, but one is from Argentina, that is an engineer, that he wants to listen you, know me. Is it can be this agent used in automatic extinction system like sprinklers, for example, for automatic extinction in closed room, facilities in buildings where generator sets and place and gas oil leaks can occur?
Yes. So, you know, that's what we have here. That's what this is here is the F500 being added directly into the sprinkler system. Currently work here in the US with quite a few of the power companies protecting both transformers, so energized, you know, transformer equipment, under turbine lube oil where that the energy is being produced. Again, both for those flammable liquids type fires and those, you know, three-dimensional type fires. So yes, it can absolutely be added into that sprinkler system to pretty much protect any facility.
Okay, I answer in Spanish, but he wants to listen you.
Okay.
He don't believe me in Spanish. Say, okay, you will receive the answer in English. That's they know more. Okay, thank you, Ronald. We have other questions. Say that if you have a machine shop or business working with combustible metals, then A500 is something a fire inspection or a fire company doing a pre-fire plan may suggest the owner have available. Is that reasonable to ask a company to do?
That's generally what I will tell most of the fire departments that I work with. If we're going out and they have these hazards in their community, it's that industry's hazard. You know, so how I would preface it if I was the fire chief is, it's your hazard, and this is a good solution to control that hazard. So you can help us by having a supply of it here at your facility to help us fight this hazard, or there's really nothing we're going to be able to do other than protect the area around it and allow that hazard to burn and potentially have a larger loss for that company. Because really, if it's a fire involving a Class D metal and you don't have something like F500, you're potentially, trying to drive an excavator filled with sand into a hazardous environment to dump a bunch of sand on top of some burning metal to try and put the fire out. Hazardous and dangerous for the equipment operator, for everybody involved. So I think you can make a good point. It may take us going out and educating that facility owner, which we're happy to do, to come out and work with the fire department to show them the benefits of adding F500. And I think we're actually pretty successful with doing that.
Yeah, we can even go, Ron, just to go on to it. I mean, we do have companies that have already put systems in. So, I mean, we can be helpful in sharing that information so that they don't think that they're the first facility that's being asked to do it.
Yeah, exactly. Yeah,
Like you
we
guys-
actually, I have quite a few facilities, both manufacturers of Class D metals and recyclers of Class D metals that are using F500 and storing some of it for the fire department in the event that it's something they can't handle with the extinguishers and stuff they have on site.
Yeah, and I can pipe up here and say, even though NFPA 423, which is the Combustibles Metals Code, says don't use water on Class D magnesium. In other words, don't put a water sprinkler system in. I can cite at least 2, maybe 3 facilities where they moved in and there was a sprinkler system already in place, and the fire marshal would not let them take the sprinkler system out. After we met with the facility and met with the fire marshal, and they fully understood that by adding the F500 into the sprinkler system, you're changing the configuration of the droplet. You won't have the explosion. So we currently have multiple fixed systems in place protecting Class D metals. So, again, the fire marshal's initial reaction was, oh, no, you can't do this. But then upon being educated and actually seeing it, they approved the systems.
Bob, thank you everybody for your time. I hope you find that informative and, maybe gave you some answers to some solution or to some hazards that either A, you didn't know you had, or now that you realize that you have, and there is a good solution out there for them. And that solution is encapsulator technology. So, look forward to continued communications with everybody, and, let's make the world a safer place by encapsulating it. I look forward to working with all of you.
Thank you so much.
Thanks, everyone.
everybody.
Enjoy your evening.